Welcome to the end of week 15, day 3. And we are going to go over the BST test because a lot of you guys had trouble with the quiz. Let's see, let me pull it up here. There we go. All right, so the average score on the BST take 1 was a 50% or 59%. The modal response was about 50% on it. It's not good. And there was a bit of trickiness on it. So let's go through the questions. The first thing, what is the big O running time to print all of the elements in a balanced BST? There is no way you can get faster than order n. There's n elements. N means how many elements you have in a data structure, right? So if you have 1,000 elements in a data structure, there's no way you can print them faster than 1,000, right? I guess you could pre-compute it. I don't know. It's order n. There's no way of doing it faster than order n. And a lot of people just jumped on the fact this is a balanced BST and went like, oh, well, for balanced BSTs, it's log n for everything. And again, this is why you have to understand what's actually going on. To search for an individual name in a balanced BST is log n time. To delete, to insert, search, change, they're all log n. But to print all of the elements in a balanced BST is order n. It has to be at least order n. Okay. And and it could be worse actually. Like if you were to somehow do it by like searching for each of the names, search for A, search for B, search for C, then it would actually be in log n. But when you do a print function, it normally is a recursive function that goes left and right, through the tree. That's an order n operation. Okay. It's bigger running time to insert into an unbalanced BST. That's order n. Some people said log n, maybe not knowing what unbalanced meant. An unbalanced BST means this, right? And so a balanced binary tree, the max height is going to be log n. And so in order to get to any spot in a balanced binary search tree, it's going to be log n operations. For a unbalanced tree, all of them could be to the right. And so the worst case scenario is if you're inserting into an unbalanced binary tree, you've got to go to the right, go to the right, go to the right, go to the right, n times, and then insert. So this is basically a linked list with more steps, right? So yeah, unbalanced, balanced. Okay, and so the big O running time on a BST depends upon whether or not the tree is balanced or unbalanced. And there are data structures like the set class in the standard library that guarantee that it is balanced. The code that you guys have been writing doesn't have any such guarantees. You learn how to do that in junior level computer science. Okay, what line of code is wrong? It's supposed to find an element in a BST. It's a boring BST, yeah, okay. So this is a search function. It's taking a data by reference. It's going to be searching for whatever type it is. It could be int, could be string, we don't know. And so we're going to start at the root. We're going to start at the head of the tree. We're going to say while the pointer is not null. I don't know why some people thought A and B were wrong. These are fairly... yeah, originally, there's actually two versions of this. Originally, I didn't have the node pointer here. And so, yeah, A was wrong for a good number of people, and they got credit for it, don't worry. I changed it mid-quiz, because I was curious to see if anybody was going to cheat. So it reveals the answer, and then if you get from your friends the answer is A, then it is revealed. Okay, so while the current pointer is fine, that means while the current pointer is not null. So for those of you that put down B, this is actually fine. This is a shortcut for while current pointer is not null. If the data equals the data, return true. So 4 people put that down. No, that's fine. You might be like, oh, but that's data and that's data. Yeah, totally different. Totally different data, so that's fine. If the data that we're searching for is greater than the data of the current node we're at, go to the left. No. If the data we're searching for is greater than the current node, we need to go to the right. So that's why that one is wrong. Otherwise, go the opposite direction. Technically, I guess, E is wrong also. But that's a mistake right there. Right? And so if you fix that, it'll fix that as well. And then if you get through this whole thing, eventually it'll hit a null pointer, the loop will terminate, and it will return false. And then we had 28% of people able to write a function to print a function from greatest to smallest. Most common mistake was printing a tree from smallest to greatest. Some of them were quite clearly copied from other websites because it came with the formatting of the websites you copied it from. So, yeah. So most printing functions are going to print from smallest to greatest. That's why I pick greatest to smallest. You can just copy and paste from Stack Overflow or something. There were a lot of implementations that would segfault. They didn't check for a null pointer. So the answer is this. Print tree taking a node pointer and if n equals null pointer. If n equals null pointer, then return. Otherwise, we will print tree to the right, because we're doing greatest to smallest. Then we're going to cout endpoints to data. We're going to print the tree to the left. Okay, that's it. That's the whole thing. And what I've noticed with this and with the linked list thing is that you guys a lot of you don't have enough practice writing code with linked lists, and so I guess I can give you guys just a bunch of homework assignments to do that. But what kind of data structure you use for the histogram? You have to know how to match your unsorted order. I used an array for the histogram. I used an array. That's it. I didn't use an unordered map or a set or any of that stuff. I just used an array. There's only 128 possible values. I made an array of size 128. Every time an A comes in, every time an A goes in, I go to array element 65 and increment the count by 1. That's it. And you just go down the thing and print them. Why do you only cout endpoints to data one time? That's... What do you mean? Why would I print it twice? So what's going to happen is if, let's say we pass in root here, then it's going to call this on the root's right node. Let's say that's null. So we get into that function. The thing passed in is the parameter is null. It returns. It'll then print root's data. It then calls the function recursively on the left subtree of root. Let's say that's null also. Comes in here, it returns. So it is printed just the root and nothing else. Now let's say we have a right subtree. We need to print everybody in the right subtree before we print our current number because we're printing greatest to smallest. And so this is going to print everybody in the right subtree, then it's going to print our value, then it's going to print everybody in the left subtree. So, yeah. You need to learn to think with portals, or pointers in this case. Yeah. So I think that Muya, you want to do a lecture on going over pointer algorithms? That be a good idea. Yeah. Okay. Okay. Yeah. So the trouble is there's only so many things you can do with binary search trees, and you've already kind of written as a homework assignment, insert and search. We haven't had you do delete. I guess we could give you a delete assignment. That'll just be the entire take 2 for binary search trees. Just write binary search tree delete. For my 3090. Oh, hell no. Can you draw it on OneNote? Sure. I mean, I like you guys, but the reason why I teach is so that I can buy stupid stuff for my computer. Not the other way around. Okay. Okay, so we call print, we pass in root. So we're going to call print passing root. That'll be like in main or something, right? Something like that. This code here will print out nothing, right? We pass null in, returns. Okay. What's the rest of the specs on my rig? That's a good question. Let's see. I have a, what is that? 6 terabytes free. I have like an 8 terabyte. Is it 8 terabyte or 10 terabyte? I think I have a 10 terabyte M2 SSD. I've got a 15 terabyte spinny disk. Got another couple terabytes of SSD space here. Got a total of 367 drives in my computer right now. Yeah, so I have a total of 27 terabytes of hard drive space right now in my computer. And you can see that game development eats up a huge amount of space. I only have 32 gigs of RAM, but that seems enough. Like I don't really seem to need more than that. 32 gigs of RAM. I don't know. It's using about half right now, but I don't know. And then I got a 3090 graphics card. Please don't come to my house and rob me. I'd appreciate that. So, yeah. CPU is a 7900X i9. So, I teach summer school basically to just get stupid crap for my computer. Yeah. 4 pounds of gold is $93,000. Yeah. Yeah, it's fine. Game development actually is fairly demanding, and I teach game development, so you know it's not like this is just flexing or something like that. Like I literally kept running out of hard drive space, and I kept buying more hard drives and SSDs. Just told all my students projects, because they'll just be like, "Here's a terabyte of data." Like, what the hell, dude? So, yeah. Teaching game development is both a source of revenue for me and a source of expenses because it is highly demanding on my hard drive. Okay, so how does this work? We call print root, and so let's trace the flow of execution here. Right? How can we do here? Split screen, split screen. Out of the way. There we go. There. So let's trace the flow of execution. So we call print tree on root, and let's ignore this and just say this is what we have set up in memory right now. So we come into here, root is not null, So then it calls print tree on the right. And so it's going to call print tree on the right pointer, which is pointing to this person. We come in here, is that guy null? Nope, we got a valid pointer here. So then it calls print tree on its right kid. Okay. And then that one calls print tree on its right kid, which is null. And so that returns, coming back up the call stack, it will then proceed to print 20 to the screen. It then prints the left child of 20, which is null. So it comes in here, does nothing, returns. So we've now printed 20 to the screen. Then comes back up here. We just printed the right subtree of 10. And so we now print 10. And then we print the left subtree of 10, which is going to print 7. And then that returns, and then that returns. So we've now printed the right subtree of 5. So now we print 5. And then we print the left subtree of 5, which is going to end up printing 3. And so this is going to print the numbers from greatest to smallest in about 5 lines of code. It's a very complicated thing to do if you try to do it iteratively. The way that most people do this is not trying to write a for loop to go up and down and left and right and stuff like that. They typically use the stack class. And so if you have a job interview and they say write a print tree function that does not use a recursive implementation, then the most common response is like, okay, I'll just do the stack myself. And so you hashtag include the stack class, and you push things onto the stack and pop things off the stack and basically simulate the stack, the call stack that way. So you could use online storage, except I have run through my terabyte of bandwidth that AT&T has given me for this month. Apparently all the streaming and uploading I've been doing has destroyed my bandwidth maximums. And they want to start charging me $10 for every 50 gigs of data I download. Yeah. So I used a terabyte of data this month so far, as of a few days ago, and the month isn't even over yet. And so if I were to say use another terabyte, or let's just say I'm going to patch Microsoft Flight Sim, which apparently is 500 gigs of data, that'd be what, $100 to patch a game? Screw you, AT&T. I am now going to do the unthinkable and talk to Comcast. So cool times right there. Yeah, so there's a YouTube video called "If Programming Was an Anime" Part 2, and this is literally the job interview question he's given from Google. And so I'm not going to post this because I don't want a copyright strike, because YouTube is ridiculous and doesn't understand what fair use means. But yeah, that one has literally this question on it. And Comcast is the best. Comcast is an evil company. But I'm willing to make a deal with an evil company because AT&T has offended me. Yep. Exactly. So I'm going to go into the Comcast store, and I don't know, I might just call up AT&T and be like, I'm going to cancel. And whenever you try and cancel, here's a life pro tip. Call up your service provider and threaten to cancel about once a year, and they will cut you a deal for the next year. So I can be like, it's too expensive. They're like, how about we knock it down to $20 off a month? All right. Well, I also don't want a data cap. Okay. Yeah, we can get rid of the data cap, but they only make the deals for a year because it forces you to call back and cancel every year, and most people are too lazy to do that. I'm too lazy to do that, but right now I'm upset enough by that because when I purchased, I have their top tier internet, and when I got it, there was no data cap. The data cap was on the plebeians, the free tier or whatever it was of DSL. Now they've put a 1 terabyte data cap on the top tier of service they have at AT&T. Screw you, dude. Screw you. Hell no. Not putting up with that. Data caps are evil. Yeah, and there's no justification for it. It's not like if I don't use data, like they have more data in reserve. Like all routers operate on a flow basis. Routers have a certain capacity, and if you're not using the capacity, it's wasted. So, There's legitimately no justification for a data cap, but they have a duopoly and they get away with it because who's going to tell them not to, right? So Starlink is coming to Fresno. Yeah, I don't think it's going to be very good, or at least I don't think it's going to be as good as what I have right now. But for people out in like Yosemite Hills and things like that, yeah, it should be nice. Most of our customers never reach a 1 terabyte data cap. Yeah. The last patch for Microsoft Flight Simulator was 500 gigs. It took me 24 hours to patch Microsoft. That's one game and one patch. You know, and then I got my kids streaming on Zoom. I got me streaming, my classes, my wife's, you know, watching Netflix or something. Yeah. Yeah, we blew past the data cap 20 days into April. So, yeah, rant over. Okay, so with the linked list competency exam, let's go over that one too. The thing is, you just need to get more practice writing code like this is really what it comes down to. And I've already given you a homework assignment on this, the Dungeon Delve assignment. If you haven't done Dungeon Delve, you're probably gonna have a hard time. I'll probably go back and just do that. Xfinity internet data usage. Yeah, Xfinity has data caps as well. 1.2 terabytes. Yeah. If you pay, I think $15 a month, then they'll get rid of the data cap. So at $130 a month, you can have unlimited internet, like it should be, like it used to be, until they discovered they could squeeze more money out of people. So more power to them. All right. So yeah. All right. What's another example of like a binary tree that we could do? Let's not delete. Pay $50 a month for 150 megabits a second. That's pretty good. Yeah, I'm still waiting for fiber. They promised us in the late 90s everybody would have fiber. They were digging up streets everywhere, putting fiber in. Fiber to the home. And then they got away with... They took billions of dollars in subsidies to install fiber, and then never actually installed or gave most people the ability to actually get fiber. They installed fiber up to the box and then said, it's good enough. So there's no ability for most people to get fiber. It's a ridiculous situation, honestly. It's completely ridiculous. Okay. What other things could we do with binary trees? Anyone? We could do a rotate, maybe. Yeah, okay. So Moya will do a review of pointers and linked list stuff for you guys. Let's see, let's go over the next thing. I think there's one more take on linked lists before we're done with that. I'm doing no more than 4 takes this year on each subject. But you need to develop it. Like if you're feeling awkward about, you know, those coding questions, it's just a matter of practice. It's like learning a foreign language, and you just got to write code. So let's see here. Linked list, take 3. You guys did pretty well on it. So this is a normal linked list class. Supposed to print out the whole list. It's segfaulting. Okay. So this is your standard for loop for a linked list. For starting at the beginning until it's null, going to the next. So this is going to iterate through a linked list, and it's going to print out temp points to next points to data. So the problem here is that it, on the very last node, temp is not null, but temp points to next is null. And if you dereference a null pointer, it's not, like a lot of people think that even like breathing on a null pointer will cause the segfault. No. If you were to say if temp points to next double equals null pointer, that's fine. You can read, because null pointer is just a 0. It's when you do 0 right arrow anything, with an exception that Moya saw yesterday in CSI 45, which is hilarious. But if you say 0 right arrow data, that's a segfault. Just reading 0 or comparing 0 with another 0, that's not a segfault. What segfaults is when you have the arrow operator with a null pointer on the left side. That is a segfault. Okay, and so this code is going to segfault guaranteed segfault on the very last node of the linked list. It's going to grab a null pointer and try to get the data value of the null pointer, and that's going to segfault. Okay, in plain English, what is this bit of code doing? Key is a variable of whatever type data is. Okay, so standard standard for loop to loop over a linked list. If temp points to data equals key. So if we have a match on the parameter we passed in key with data, then if temp points to previous, so if the current node that we're at has a previous node, in other words, if temp points to previous is not null, in other words, we're not the head. If we're not the head, then temp points to previous equals temp points to next. That's actually a bug, I think, actually. So it should be temp points to previous points to next equals temp points to next. If temp points to next, then temp points to next points to previous equals temp points to previous. So this is, if we are not the tail, then the element after us, their previous pointer, is our previous pointer. That is a typo, though. Let me fix that. Fortunately, segfault was not one of the. It's not one of the options. If we are not the head, then our previous person's next is equal to our next. And if our next pointer is not null, then the person after us, their previous is our previous, and delete temp. So this is going to do a delete operation. So this is a classic linked list delete function here. Okay. Save quiz. If you don't hit save, then it doesn't save. Okay. All right, so this is going to erase everybody that matches key. So it's going to loop through the entire linked list and delete everybody who has a data value that matches key, which 95% of you guys got. One person did not. I see. Okay. I know who that person is now. Okay, in terms of big O, linked lists are faster than vectors at deleting from the middle of the data structure, even. Got a lot of you guys at this one. So normally, yes, normally linked lists are faster than vectors at deleting from the middle of the data structure. However, if you do not have a pointer at the middle of the data structure, you have to loop through the linked list to get there, and it's going to be an order n operation. So if you have a pointer to an element in the middle of the linked list, you can delete it in order one time, whereas with the vector it's order n. If you don't have a pointer there, though, and you've got to search for it, then that is order n operations to get to the middle of the linked list, technically n over 2 if it's the exact middle, which is order n. And then you can delete it in order one time. But yeah, this is the reason why linked lists aren't commonly used. Their one main advantage only works if you've already iterated to get there, right? So if you are doing a thing where you're going through a linked list, and something like this actually, where you're going through it and deleting everybody that matches something, then maybe that's going to be more efficient. But no, you can do that. You can do that efficiently with a vector as well. What you do if you're going to delete everybody that matches a key in a vector, what you do is you go through the vector, and every time you find a match, you swap it with the end. And so let's say you're deleting the number 42 out of a vector, and there's 7 of them. You loop through the entire vector, and you take all the 42s and swap them with the people at the end, coming backwards this way as you swap. And then at the end of it, you just pop off 7 elements. So there's, in real life, there's rare situations where a linked list is actually really needed. After deleting in vector, one vector reallocate all of the following elements. Yeah, but you don't have to delete. You can swap, right? So let me show you what I mean here. So let's say you wanted to delete all 42s. So the naive way that you could write this was you could search for the first 42 and call erase, right? And then erase will pop that guy off and move this guy here 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 and move this guy here, right? And so each delete would be order n, right? If you wanted to delete all 42s out of this thing. Then you would have to do this n times. And so this would be order n squared to delete all 42s out of a vector using this sort of naive implementation. However, if you're clever and you wanted to delete all the 42s in a more efficient manner, you would do this. You go through here, that's a 42. So you swap -8 and 42. Move to the next one. That's a 1, leave it alone. This is the same vector, by the way. I'm just showing you what's happening. Oh, that's a 42, switch it in -7. That's a 3, leave it alone. 42, and we're at the end, so we're done. And then it just calls pop back 3 times. Okay? And so doing it this way is order n, not order n squared. Because you loop through the entire vector, and every time you find somebody, you don't erase it immediately. You just switch it, right, or something like that, you know. And so if you don't care about order, right, that's an important caveat. If you don't care about the order of things in a vector, if you just care if they're in the vector or not, then you can do this trick. If you do care about order, then yeah, it's going to be an order n squared delete. Absolutely. How do you draw with the mouse so easily? Yeah, if I had to draw with the mouse, I can't, because OneNote is stupid and terrible. Come on. Yeah. So if you don't care about the ordering, then you can do that and pop them off. And that's a let's see, maybe no, you can actually keep the ordering. Never mind. Yeah, you can actually be clever about it, right? So as you iterate through it, you can just move people up, right? And that would still be an order n operation. 1 there, then 3, and -7, -8. Yeah, you can do that in order n time. And so you just have 2 pointers, one where you're writing and one where you're reading, and you just you do one pass over the vector, and that would be an order n. Okay, and then you just pop off the n, good to go. So yeah, even something where you'd think a linked list is better like this because it's deleting all the elements out of linked list. Actually, the vector could do it probably faster because vectors have better memory locality. They fit into cache better, oftentimes. Okay. Yeah, but for this question, yeah, the question is pretty clear, even if they don't have a pointer already to the element, right? And if you don't have a pointer to the element, then you have to iterate through the linked list to get there. You can't just randomly jump to the location. Linked lists have no random access. Okay, for this one, given a list of integers, write a program that will see out the sum of all of the data in the linked list. For example, if your list contains 5, 1, 2, 3, your code should output 11. And so 2/3 of people were able to write that code. Right? All right. So we will have more competency exams coming up. And all of them will need to be done by the end of the semester, which is also coming up. But there's no final in this class. So maybe for finals week, we'll just do a series of competency exams to get everybody having the option of taking at least 4 of them on every topic in this class. All right, so let's talk about histogramming a little bit. So for the histogram assignment, histogram.reference, basically you're going to pass in a file name, cat input file 0. So let's pass in Hamlet. Do you sort by count? No. Okay. So this is going to be, I don't know what that is, like a tab or something. And so Hamlet, it's counting how many times each letter appears in Hamlet. This is ASCII encoded. And in the ASCII encoding format, we've talked about this before, man ASCII, you can see there's only 128 possible values from 0 to 127. So you can just make an array of size 128, and every time you see a V, you can just increment the count in the count array index 118. This is something called Radix Sorting. And so it's, if you wanted to sort Hamlet by letters, you could do what's called Radix Sorting. So you just count how many times each letter appears, and then when you sort by count, or no, you don't even have to do that. Like if you're just sorting them all alphabetically by letter, you could just print 1,601 A's, 242 capital B's, 485 C's, and thus you could sort all of the letters in Hamlet in order in time, not in log n. It's actually faster than the provable maximum. Radix sorting is faster than the provable maximum speed of a sorting algorithm. A sorting algorithm, the fastest possible provable running time is order n log n, and this is faster than it. How is that possible? Well, n log n, I've always been very careful to qualify for random data. In radix sorting, you don't have random data, you've got 128 possible values, this kind of radix sorting. And so if I wanted to print all of the letters in Hamlet sorted alphabetically, like all the A's, then all the B's, then all the C's, I could do so by just going through and counting how many times each letter appears, and then printing all the letters. I'll print all the A's, print all the B's, print all the C's, and I can do that in order in time. Right? Do you guys understand that? It's not for this homework assignment. I'm just talking about radix sorting in general. Like, what if I gave you an assignment where you had to sort?
Well, Karen, I have a question about the unsorted, because because you used an array, you're technically sorted by alphabetical order already.
Yeah, but you have
to
to
sort. Which would mean that we would all have to also use arrays to get the same output.
Not necessarily. You just sort it alphabetically. Like the approach I showed last time with the unordered map and the set, it works fine. It's overkill. For this one, you only need an array.
I guess.
Okay, so let's say that I gave you guys a homework assignment where the user would enter a bunch of numbers. The numbers are going to be from 0 to 9. And I need you to sort those numbers in order n time, not in log n. So you cannot use std sort. Std sort is too slow in this case. How do you do it? So we got a vector of integers and vec. Then we're going to make a vec of that size. Dead silence on Discord. Let me show you guys how to do random numbers the C++ way. So we're going to put in a random seed that'll control which random numbers we get. We're going to get a size. And so we are going to make a random number generator using the Mersenne Twister 19937 algorithm. And if you are going to say, how the hell is anybody supposed to memorize that? You would be absolutely correct. You might notice that I'm copying and pasting the code here because, yeah, no, I don't remember this off the top of my head. Okay, so we're going to generate numbers from 0 to 9. Okay, so this is the ugly way to make random numbers in C++. This is considered better, and it is better than using rand. In C world, we use srand and rand, so this way is better. Except it's more verbose. Like C++ has really taken a turn for the worse in terms of how much typing you have to do. I think people were influenced by Java. Java writes huge amounts of code to do very simple things, and C++ is getting more and more verbose with every edition, which is really quite annoying. So functional allows you to do cool stuff. Like this here is going to actually make a function. It actually is going to make a function that called roll, and we can actually do something like this. Check this out. Call a roll. Call roll. Call roll. I want. It doesn't matter. It calls roll 3 times. You see that? So it is, this makes a function. This makes a function that is going to generate random numbers from 0 to 9 with this random seed punched in. And then you can just call roll like a normal function. And so you don't have to mess around with srand or rand. This here is effectively srand. This is seeding the random number generator. This is saying give us a uniform int distribution from 0 to 9, so it'll give us random numbers from 0 to 9 with even probability on each of them, which is better than rand. Rand does not actually give you equal likelihood of numbers from 0 to 9. Like if you were to say cout rand modulus 10, which would give you a number from 0 to 9, you are actually probably not going to, well, mathematically speaking, this is not going to give you even odds for 0 through 9. Mathematically speaking, like even if rand was perfectly implemented, because you're doing modulus and you're modulusing a number that's not divisible by 10, there's actually going to be a few more, zeros and ones than there are 8s and 9s in the probability space. So this is guaranteed to be not correct code, but it's simple to write. So I teach it in C Sci 40 because that is way simpler than that, right? So what this does, this makes a function called roll, and you can just call roll, and it'll give you a number from 0 to 9. Okay. But what we want to do is we want to fill vec with these numbers, these random numbers, and so we're going to use we could use a range trace for loop for every integer in vec. We're going to set that integer equal to roll. You guys see that? So this is going to fill the vector with random numbers. All of them are going to be from 0 to 9. Do you guys understand this code? Roll is a function that returns a random number from 0 to 9. And so for every element in the vector, make sure you remember the ampersand. If you don't, you're going to be very puzzled why it doesn't do anything. What is seed doing? Are they in order? They are not in order. They are just random numbers. So if we were to print out, the vector, seed's the random number generator. So every time you type in the same seed, you will get the same random numbers out. So you can have non-random random numbers. This is why I do this on autograders, because if you're generating random numbers, I need to make sure the random numbers you get are the same as the random numbers I get. That way the autograder can be like, yeah, that's correct. You know what I mean? If you don't want to use the seed, you could use, I don't know, the time, or I think if you don't pass anything in, then it'll default to, I don't remember what it defaults to actually. But like you use the time, or there's actually different sources of randomness you can feed into it as well. For example, you can feed in the temperature of your hard drive and atmospheric noise and things like that to actually make a random number generator. But seed gives you non-random random numbers. So let's print out all the numbers in here. So for every integer in vex, see out the number. Oops. Let's try that again. 10 random integers with a seed of 1. So I get 4, 9, 7, 901, 3912. Cool. Now if I do this again, 10 random integers with a seed of 2, I get, rather than 149, I get 410, 959, da, 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 da. Now what if I tried a random seed of 1 again? 10 and 1. Look, I got 149 again. See that? So the random, 497 again. The random seed controls the random number generator. So every time I use the same seed, 10 and 2, see that? I used 2 as a seed before, so I got 4109. I get 4109. So I can control the random numbers that come out. If you've ever played a video game called Civilization or Valheim or a lot of games, you can actually, when you create a world, you can actually type in a random seed. And so like if your friend has a really cool Valheim world, they can share their seed with you. And if you punch in the seed, that it will generate the same random world that they got. And in Civ, if somebody's got a cool, map, they can take the random seed, share it with you, and then you could punch in the random seed and it'll generate the same random map that they had. So every time you use the same random seed, you will get the same random numbers out. Okay? And if you want it to be actually random, then you don't use a deterministic seed like this, but you use entropy and noise, and it's actually really hard to do really good random numbers. The CIA has satellites pointed at the sky that just read atmospheric noise as a source of randomness for their random number generators. Okay. Age of Empires, SimCity, yeah, Minecraft. Yeah. Okay, so what are we going to do with this? We want to sort all of these numbers, right? We want to sort all of these numbers, and we want to do it in order n time. Order n time. That's faster than is theoretically possible. Let's see if we can break mathematics. Okay. See out original array. So it's called Radix Sort. So in this case, the numbers we're sorting have a very constrained range, only 10. Right, so this is only practical if, like for what you're doing right now with histogramming, ASCII only has 128 possible values. If we were to do this with Unicode, I don't know. We'd probably have to use a hash map in that case, a hash table in that case. But this is a really nice method when there's a very limited range of things. The values of the things you're going to sort have a small range. It's called Radix Sort. Okay, so what we could do is say int array of size 10 and initialize a to 0. So the array is going to be filled with zeros. Or we can use a vector events named count array of size 10. Either way, same thing. And that'll zero fill by default. If you ever want to fill something, you'd always say fill vector.begin, vector.end, fill it with number 1,000 if you want. And there's also a standard library function called generate. So if you don't like that, which I kind of do, I actually kind of prefer this. Generate, you always say generate vector.begin, vector.end, passing in the role. And this will fill this line of code here does the same thing as that line of code there. It's more verbose though, so I don't really use generate very often. But what it's going to do, it's going to call roll on every element in vector. So from the beginning to the end, it will call roll, and the output of roll will be saved into the vector at that point. So that's, you'll see people use this to fill an array with random data, but it's more verbose than this. So yeah. There's a lot of standard library stuff that actually involves more typing. There's reasons to use them, but yeah, for this purpose, it doesn't matter. So let's do your homework assignment. So for every integer in the vector, count square bracket x plus plus. There you go. There's your homework done. So if we go through the vector one at a time, okay, this number is 6. So we go to array element 6, and we update the count by 1. So it starts at 0. First time we see a 6, now it's got 1 in it. Okay. And then we read another 6. Okay, count now is 2. We go to square bracket 6 and upgrade it to 2. Technically, I don't even need curly braces. Okay. So there's your homework assignment. Right there, all done. And then we just need to print it out, or rather, we want to print out the numbers sorted, right? So print the numbers in sorted order. Okay, so it's a lot of pink, man. Hurt my eyes. Okay. For int equals, for size ti equals 0, I is less than size. I is less than 10 I plus plus. So actually, let's see here. Yeah, okay. So for every index in the count array, for int j equals 0, j is less than count square bracket I j plus plus. See out. Okay, so let's say that the count array at square bracket 0 has 5 in it. So I is the current number we're printing out, 0. And this is going to say, get how many times 0 appeared in the input? 5. So 5 times it is going to print the number 0 to the screen. Then I updates to be 1. Let's say there weren't any 1s. So this loop, the inner loop won't run at all, skips over it. I is now 2. There were 10 2s. So 10 times it's going to print, count would be 10 in that case. Count square bracket 2 would be 10 because there were 10 2s. So print out 2 10 times. And so basically this is it. Okay, so G++, .cc. Numbers is a seed of 1. So we see here we have our original vector 49790139112. So we count how many times 9 appears, right? 9 appears 3 times, and so down here our loop is going to print out 9 3 times. 0 appeared once, so we print out 1 0. 1 appeared twice, so we print out 2 1s. And so there you go. So here is a sorting function that runs in order in time. What do you guys think? And this is essentially what you're doing for the histogram assignment, except you're not printing the letters in sorted order. You're just printing the count array, right? So after you do the counting, you just print the count array, and then that's it. That's part one of histogram. Then part two, you sort it by the count. Are you guys still here? Are you still live on Discord? There's like been silence on it. Not a single thing's been typed in 7 minutes. Okay. So that's it. What do you guys think? So you're going to count how many times each of the numbers appears. And so if you had 5 zeros, you're going to print 5 zeros. If you had 2 ones, you're going to print 2 ones. For Radix Sort. For your homework assignment, you're going to do a histogram. You're going to count how many times each letter appeared. Print out the count. And then you're going to sort it by the count. And so in order to do that, I'll let you figure out how to do that. But remember, when you call the sort function, you can pass in a third parameter. So for example, you can make a class that has the letter and the count, and then you can have a lesson operator that will sort based on count first and the letter second. That's how I would do it. Do you guys remember that? Operator less than, right? So make a struct for the histogram that has the letter and how many times that letter has appeared. And then after you've counted it, sort it based on the count first and the letter second. And then you're done. That's the whole homework. You want A23 or 23A? I don't remember. Let's see here. CD histogram preference. Letter E is quite popular, it seems. T is more popular than S. That's interesting. Do you want to sort by count? Yes. And so it's the exact same thing. You don't put the number first. You just sort the output by count. So space is the most common, followed by E, T, O, A, S, H, N, R, I. This is new line. That's the return key, right? The enter key. L, U, D, tab, apparently M, Y. So if you ever played Scrabble, if you ever wondered why J is worth so many points, right? Q, quite rare, right? V, pretty rare. Or is Z? Does Z appear here at all? Yeah. Z appears less often than capital Y. And so J appears even less often than Z, which is interesting. That's why J is worth 10 points or something like that. Okay. Any questions about this? You got till Monday to do it. You don't have a whole week to do this one. It's just 5 days. But that's it. That's your whole assignment. So write a custom sort function. Yeah, and have at it. Again, there's dead silence on Discord. Can you guys do this homework assignment or not? Let me know. Is it doable? Let's find out if who's done it so far. CISA. Let's find out who has actually done the histogram assignment. Oh, I can tell who hasn't started on it yet. Okay, so I know who the diligent students in this class are now. Nobody got 10 out of 10, but I can tell who's working on it because you guys are passing some of the test cases. Okay. Yeah. All right. Yeah. So for the sort thing, remember you can pass in a custom sort function, or you can just use the operator less than. I think that cd histogram.reference. Yeah, so I just made a class that has the character and the count, and I made an operator less than that sorts on count, and then if there's a tie, it sorts on the character. And that's it. And the word count, 61 lines of code, right? And that's including comments and all the other stuff. Header files. Yeah. So this is not supposed to be a hard assignment. In ascending or descending order, descending order, which is the opposite of how sort normally sorts. So when you make your less than operator, make sure if it's coming out of the wrong order, just change the direction the alligator is facing. So change this into this. Okay, so there's no questions about that. I guess I'm gonna start talking about Java. Okay, so everybody, welcome to Introduction to Computer Science. You guys are going to be learning the Java programming language this semester. So you thought this was a C++ class. But it's not. This is a Java class. We learn Java here. But seriously. So you're going to have histograms going to be due on Monday, and then you're going to have one more programming assignment in C++, which will challenge all of your data structure abilities. It will be a 20-point partnered homework assignment. It will need your histogram to be done to do it. And then after that, you're going to do a program assignment in Java. So pay attention. The last week of school is Java. All right. So there are 45 different categories of programming languages. Not just 45 programming languages, 45 categories of programming languages on Wikipedia. There are thousands and thousands of different programming languages out there. And broadly speaking, there's a few pretty important categories. First is scripting languages, JavaScript, Unix shell scripting. These things allow you to write really high-level code. It allows you to spit out code really fast, do big tasks. Like if I wanted to get the names of all users on the server and cut out their last name before the hyphen and sort them alphabetically and then unique them to remove duplicates and then write code that message each of them, hey, the server's about to go down in 10 minutes. I could do that in less than a minute, right? But if I wanted to do something like the histogramming, I don't know. I don't think I'd use a shell script to do that. You know, procedural languages where you write code and sort of step by step you solve a problem and you call functions and they return, and sort of in main, you kind of do stuff. Your main solves whatever problem you're trying to solve. Object-oriented languages, which is what we've been learning this semester. C++ is both procedural and object-oriented. You can actually use C++ in a number of different modalities. It's like a Frankenstein of a language with like a procedural arm on one side and a object-oriented leg on the other side and a functional programming arm on the other side. You just saw me include the functional header file. That makes C++ act somewhat like a functional language. It is a weird Frankenstein of a language. And so object-oriented code, all the brains of the code are in the objects. And so you'll just create like Muya did for his assignment due in an hour, to do rendering of 3D objects on the screen. He just created a camera. I'm going to create a camera at this location pointed in this direction. I'm going to create some triangles, and I call render. And that's main. His main is 3 lines of code. Create a camera, create some objects in the world, and render the scene to the screen. And that's object-oriented. Object-oriented, all of the brains, all the intelligence are out in the classes and the objects. In procedural, the brains are in main, and main is responsible for solving the problem, and it might call functions and things like that, but basically main is the boss. Whereas in object-oriented, main's only job is really to set up the objects and then pass control to the objects and let them solve the problem. So reflexive languages are languages where you can do reflection. So for example, you can ask, do I have a member function named something? C++ can't do reflection yet, but we've been talking about it for a while. In 2017, when I was at CPPCon, they were gathering information on use cases for reflection. I put up my hand. I'm like, look, I'm a professor. I'd like to be able to grade my students' classes. I'd like to be able to say, did they make a constructor? Did they make a destructor? Did they make a copy constructor? Did they make a move constructor? And right now in C++, the only way you can do that is you can try calling, these functions, and if it doesn't compile, it doesn't compile, and they get a 0. But that's like an all or nothing thing. Like if I try calling all of these things, and if one of them wasn't done, you get a 0. And what I'd like is to have the ability to say, if they have a function called getX, call it. If not, move on, right? And there's no ability to do that in C++ right now. Maybe if you get really fancy with like macros and things like that, you can do it. But basically, there's no way of doing it in C++. Functional programming is a weird way of coding. You'll learn about this in junior level coding. Everything's basically a mathematical function, no side effects. So something like cout isn't possible in a functional language. Or if it is, it breaks the functional paradigm. It's called a dirty functional language. In junior level computer science, you'll take a programming languages class, and you'll learn, at least if it was like my class, you will learn a new programming language each week. So each week you will learn a new programming language. And that seems impossible, right? Like it's been a year and we're still discovering new corners of C++ we didn't know existed before. And in CSci 45, I exploded their brains yesterday by showing them how they could dereference a null pointer and do stuff with it without it segfaulting. And that was funny. Yeah, so in programming languages, you will learn a new language a week or something like that. And write programs in it. Basically, what we did in my class was we wrote a Riemann sum calculator. In calculus, if you have a curve and you want to compute the area under the curve, it's an integral. You can compute it by putting like a rectangle underneath it and kind of adding up the areas of the rectangles. And you can make the rectangles narrower, and that will approximate the area under the curve more and more accurately as the rectangles get narrower. We had to write that in Pascal and Algol 60 and Camel and like in all these different languages. We had to write this integral calculator in a bunch of different languages. Limit set to infinity. The sharpshooter was wrong. So Java is an object-oriented language. Okay, Java is an object-oriented language. It was actually Java came from. In my opinion, I don't actually know. I can't read their minds. But if you want to think of Java as C++ that's safe, that's probably a good way of thinking about it. The people were like, you know, things like memory allocation and deallocation are too hard for humans to do, so we will get rid of the ability of humans to at least deallocate memory. It really, in order to do anything, you have to allocate memory. So in Java, they basically have removed all responsibility for memory allocation, memory deallocation from Java has no pointers, so they thought pointers were scary. So there's no pointers in Java. They're all references. Every object's a reference. It's not a pointer. So there's no arrows, no stars, that kind of stuff. Every time you do bounds checking with an array, it will bounds check for you. Every time you do an array access, like if you say r square bracket 100, it will check. Java will check to see if that is in the array boundary, and so Java is safe. Java, you cannot go out of bounds. You cannot corrupt memory. You cannot use memory after it's been freed. You cannot double free. You can't, like if you have a pointer to something and that thing gets deleted, you can't use that pointer. Like all these things that caused bugs and hacks over the years in C and C++ are just not in Java. It's just not possible in Java. If you try going out of bounds with an array, it throws an exception. It does not allow you to read that memory. It throws an exception. If you don't catch the exception, it kills your program. If you don't catch the exception, or if you do catch the exception, then you can handle it and carry on your merry way. But you still can't access that memory. Okay, so you cannot access memory you don't have access to. You cannot corrupt memory. You cannot do really any of the bad things that you can do in C and C++. And that's why a lot of people thought that Java was a good language to teach beginners, because it was safe, right? In C++, if you have an array of size 10 and you access array element 10, it'll work. You can read and write to it, even though it's not in the array. An array of size 10 goes from 0 to 9. 10, square bracket 10 is outside. And you can read and write to it, and it'll work. And then one day, your bank account balance is just in memory next to that array, and then your bank account balance gets overridden by whatever you're trying to write into the array, and your code crashes, and you're like, what the hell's going on? You don't know why. And you print out the value, and you're like, it's 9 million. You're like, what? I had 10 million yesterday. What happened? C++, it will just invisibly corrupt memory and things like that. Java, it is not possible. And so in C++ nowadays, we have address sanitizer, and address sanitizer makes C++ effectively as safe as Java. But back in the day, this is the mid-90s when this was made, there were no such tools for C++. And C++ was kind of hot garbage when it came to tooling support and trying to figure out where exactly you were corrupting memory and things like that. So Java, the way that Java works is that you actually don't make a program in Java. In Java, you actually don't make an executable. You don't make an a.out. You don't make something that the operating system can run. Instead, what you do is you make a program that runs on something called the Java virtual machine. And so if you make a Java program, you can't actually run it. You have to run it inside of the Java virtual machine. So if we take our classic hello thing here, so let's see. So if we look at Kate's code here, import statements are basically hashtag includes. And then everything in Java is inside of a class. Everything in Java is inside of a class. Main is a public static function inside of the class that is going to run. And so we've got a class here called rainfall, and she's got a function here called find max that goes through a list and searches for the maximum value in it. And then she's got a main, and the main sets up a vector array list of vectors, and it does stuff, and She has cins and couts, except they're called system.out for cout, and system.in uses something called a scanner. But if you look at the code here, it looks very similar to C++, right? You got an int, here, and you got an if statement here, and an else statement here, and else ifs, and yeah, it's for every integer in the vector. Like this code here could be C++, right? There's nothing in that highlighted block of code that wouldn't run in C++. It's very similar. Java really is C++ with safety guarantees added to it. Okay, can you use any language in Vim? Yeah, Vim has support for like, I don't know how many different languages. Assembly, Java, C#, whatever. And so, there are some differences, like, cout is system.out instead of cout. And, you instead of a vector, you use array list and things like that. But by and large, like, you can look at the for loops and the control flow and all that stuff, and it's all basically the same. So you can literally learn Java very quickly, and that's what I'm going through. So the process of actually compiling Java looks like this. So we'll say javac rainfall.java. That's the Java compiler. And so when we compile it, it takes this .java file, that's like a .cc file, .java file, that's our text file, and it compiles it into something called a .class file. That is the compiled version of this. Okay, but you can't run it. You can't just you can't be like rainfall. No, it won't run. Instead, it has to run within the Java virtual machine. So you say Java rainfall.class or Java rainfall. And now it runs. So there's a program that reads your program. And the reason why it works this way is because as your program runs, the Java runtime is sitting there saying like, okay, they got an array that starts here and goes here. Oh, they tried accessing memory outside of it, die. Right? And so the Java virtual machine will sit there and bounds check every memory access you do and make sure you're not corrupting memory. Okay, so if I enter rainfall 1, 2, 3, 4, 5, 45, 5, -1. Average daily rainfall is 11. Number of days that had rain was 5. Top 5 days of rain. Okay. So it basically works exactly the same way as C++, just with some differences. But the compilation process is a little different. You use Java C, and you run it by using, you have to run the program inside of the Java virtual machine. Okay. So this is your hello world in Java. Whatever program you're going to run, like I type Java rainfall, in this case I would type Java hello world. The name of the file has to be the name of the class. And then when you run a program, you type in Java hello world, and it will look for a main within that class, and that's where your program begins. Okay. So instead of cout, you use system.out, but like you saw from that code, like it's basically the same. Inside of Java, they got ints, they got longs, they got floats, they got doubles, they got shorts. These are all basically the same as C++, except they are fixed in size. It's actually a good idea, in my opinion. C++ defaults are dumb. Right? Sure. C++ picks things that are dumb and fast and unsafe and fast. And so in C++, if it will be faster on your platform for an integer to be 16 bits than 32 bits, ints will be 16 bits, maybe. And so there's no guarantee when you move your program from one platform to another that your ints will stay the same size. They could change in size. And all your bit fields break. Right? That's why I tend to use uint64 or uint32_t. Because that guarantees the number of bits. In Java, they always have the same number of bits. You got a byte, which is 8 bits, short 16 bits, int 32, long 64. Flat. Done. That's it. End of story. Floats are always 32 bits, doubles are always 64 bits. You have your Boolean type, which is going to either be true or false. And you've got chars, which are actually 16 bits instead of 8 bits. And these are wide chars. They support more than just ASCII. You have a string class, like in C++, except it's capital S instead of lowercase s. Variable names are the same. You can make uninitialized variables, like you can say int x, that's fine in Java. But if you ever try printing out the value of that, it'll throw a compiler error. The compiler will, it's not even a warning, it'll be a compiler error. You cannot use an uninitialized variable in Java. period. What's a string literal? Double quote, hello world, string literal. Okay. So in C++, double quote hello world is actually not a string. It's not string class. It is a char star. It's a char pointer, const char star. So it's a pointer to a character array because it's the legacy of C world, right? So in Java, if you have double quote hello world, that's a string, which in C++ you can get via that. So if you want hello world to be a string class instead of a char star, const char star, you can tag an S at the end of the double quote, and that makes it a string class. So that's useful if you're using like auto. In this case, S is going to be a string. In this case, S is going to be a const char star. And this is something that bites a lot of new computer science people because they think, well, that's a string, right? We call it a string. It's not a string class string because that's from C world. So that is how you would have to do that if you're using auto. String literal is the text itself. It is, yeah. Okay, so they also have what are called boxed types, and so they have a capital I integer, a capital F float, capital D double, and so these are actually not primitives. Like in C++, you have primitives, which are your ints and longs and doubles and things like that, and you got classes, right? Same thing in Java, except they've made class versions of double and int and short and everything, and they just capitalize them. And so if you use a capital double thing, then it's an object. It's not a primitive. It's a variable of type double, class double, and it's got member functions on it. So there's member functions on it, like to convert to a string, which is really nice. So in C++, you have to go like cout to string 5, like that. But in Java, you can say integer 5 equals 5, and then you can cout 5 dot was it to string something. And so in Java, there, if you make a capital I integer, then it's got functions like converting to a string and serializing and things like that. So box types are pretty cool. And it'll convert to and from a primitive and a boxed type essentially automatically for you. Instead of const, they have public static final. You know how I was complaining earlier about Java being a verbose language. It's a verbose language. Why use one word when 3 will do? So if you want to have a const for like array size, you would use public static final int array size equals 100. Whereas in Java, this would be constant. Well, public means that it's publicly accessible. So in C++, you have a public section, you have a private section. In Java, every variable is tagged as either public or private individually. So all of your variables will be like private int x, public x int y, private int z, public. So every single function, every single member variable has either the public or the private keyword on it, or you can leave it blank and use default. The default accessibility. Okay, so in Java, basically everything that is not a primitive, these are primitives, right? Your primitive types, shorts, ints, longs, floats, doubles, lowercase. Everything except for these things have to be nude. Everything in Java has to be nude. These guys, I believe, don't need to be, because of the auto boxing rule, but basically, yeah, if you're going to make an array, you say int my array equals new int 10. Or you can specify an initializer list like in C++. And so everything has to be nude in C++, or in Java. Everything has to be nude. You can't stack allocate an array. In C++, if you did this is fine in C++. This would go on the stack. In Java, no. The only thing that goes on the stack are primitives, basically. So this is going to new 40 bytes of memory. Okay. String is always string with a capital S, yeah. Mm-hmm. Yeah, in Java, they have a name, a very consistent style guide for how you should name things. And classes are all first letter capitalized, and then every word after it capitalized. Yeah, this would be snake case here, but they use Pascal case for their class names. And so everything has to be new in Java. And this is the weirdest thing to get used to it. Because in C++, every new needs a delete, right? Every new needs a delete. Not in Java. In Java, everything is newed and nothing is deleted. And that's why Java people have a hard time coming from Java into C++, is because their code works if you knew everything. It's fine. You just leak memory left and right. Because you're just not used to having to delete things, and they get confused. Like, when do I need to delete things? I've never deleted something before. They'll just stick a delete somewhere, and then their code starts crashing. Take it out. I'll just leak memory. It's a terrible. It's much better to go from C++ to Java than in reverse. So the way that Java works is that it's got a garbage collector. So the garbage collector will periodically pause your program, go through memory, and see what things are no longer accessible. It's like a smart pointer, but worse. And so it'll basically say, oh, that thing's not accessible anymore, and it frees the memory. And so in Java, the garbage collector will periodically run and free memory. And if the garbage collector doesn't work very well, then you leak memory anyway. Like I had a program that allocated a gigabyte of RAM somehow, and it didn't free any of it, even though I was, it wasn't the best designed system in the world. It was making a string by newing a string and appending a character to it, and then it would read the next character, and new a string, copy the thing over, append the character to it. It was not what you'd consider well-designed code, but Java's garbage collector got confused by it and kept all of those versions of the strings in memory. So if you write a K of memory, it allocate a K, and it allocate 999 and 998. And so it went up, the memory usage of it was the square of the size of the string. And I did that because reasons, but the garbage collector would not handle it properly, and it just kept a gig of RAM allocated to hold a K of memory. Or whatever it was. So we'll pick up this conversation next week, but probably Friday next week. We got other things to talk about, but really, what's nice about Java is that you can't screw up the whole newing and deleting thing. You just new everything and let the system handle the deleting for you. If you work hard at it like I did, you could probably break it somehow. But it's pretty good overall. Okay. And then they've got a really nice standard library too. So they've got a really nice standard library. You got to give it to the Java people. They've got functions for doing calendars and like anything. There's sockets. Their sockets interface is really nice for doing networking. It's probably easier to do networking in Java than it is in C++. And when I say probably, I mean it actually is. Yeah, maybe that'll be our final project, doing a networked program in Java, because it's actually a real pain in the ass in C++, but in Java, yeah, it's pretty easy. So, what was my big O? For that, it was an order n squared algorithm in both space and time, and I was doing that because they didn't have a string concatenate function in version 1.0 Java. They really screwed up the initial release of Java, and they had immutable strings. And so if you wanted to make a new string, you couldn't change an old string. All strings were basically constant. And so you would have to allocate a new string and then append a letter to it, and then allocate a new string and append a letter to it, which was just terrible. And so Java 1.1 added string, what are they called? The string array. I don't remember the name off the top of my head. But it added the thing that would allow you to actually do string operations. But the initial release did not, and the virtual machine I was working on had to was only version 1.0, and it was super annoying. Super annoying. Class only has 22 spectators today. Into the semester, I guess the class is getting smaller. All right. So that is that for today. And so get histograms done, and you'll get one more C++ assignment for next week, and then the last week of school we'll do a Java program. Maybe we'll do networked battle sloop in Java. I don't know. We'll see. By the way, what class you mentioned that every week was a different programming language? It was called Programming Languages. So it was literally a programming languages class, and you would learn a new programming language every week, and it was actually kind of fun because it seems like a daunting and impossible task, right? Because there's so many like nooks and crannies of every language. But then after you learn your first 3 or 4, you're like, oh, they're all basically the same. They all do for loops, they all do if statements, they all do functions, they all do variables, they all do classes, and well, maybe not all of them. So just how do they do it? And then once you're like, okay, this is how they do for loop, this is how they do an if statement, this is how they do a function, this is how they do a variable, then you just can mentally, work with it. Takes a couple hours. Yeah, it's computer science, junior level computer science. All right. Cool. Thanks, you guys, and I will see you on Monday. Peace out.